All right, here we go. Angle, side, angle. So this is another congruence theorem. Let's start off with the theorem. ASA stands for angle, side, angle. Hopefully that makes sense as to why the A's and the S's stand for that. If two angles and the included side of a triangle are congruent to two angles and the included side, sorry, my handwriting's not super neat there, of another triangle, then the triangles are congruent. So first let's talk about what an included side is. An included side is the common leg of two angles. So for example here, we have a triangle. There's one angle. Here's another angle that's listed. Yes, we could find that third angle if we needed to, but do you see how this side is the side that kind of connects those two angles? That would be your included side. Okay, so it's not two angles and some side over here, or two angles and some side over here. It's the side that ends up connecting those two angles. It's the leg that they have in common. Okay, so some examples. Let's determine if the triangle is congruent by angle, side, angle. Okay, so looking here, I have an angle that's congruent. I have a side. Now keep in mind, if the included angle has to be, the included side is congruent, that side is included between this angle right here and this angle right here. Do you see that? Angle, side, angle. We're not talking about these guys. We're talking about the side connects to the next angle over. Now my question is that congruent to, let's see, if I follow that side over, this would be the next angle. Can I mark those two congruent? And the answer is yes. Why can I mark those congruent? Because those two are vertical angles, and we know vertical angles are congruent. So it says list two sets of congruent angles. They don't give me any letters, so right now I can't really do that. So I'm going to go ahead and give these letters. If I call it A, B, C, D, E, I could say I need to list an angle congruence, a side congruence, and another angle congruence. So I could say angle A is congruent to the other angle that has one arc, would be angle E. I could say the side AC is congruent. Let's see, AC, I got to write this in order. I started with the angle with one arc, so EC. And then finally, angle C is congruent to angle C. However, we would probably use three letters here, so I'm going to say angle DCE is congruent to, now it does matter the order, D is the unmarked angle, so that would be B in this one, and then C, and then A. So there's my angle, side, angle that shows that those are congruent. Okay. Number two, are they congruent by angle, side, angle? Well, I have congruent angles here, and I have congruent angles here. Are these ones congruent? Yes, because again, those are vertical angles. And so they are congruent. Do I have angle, side, angle though? No, we're missing a side. We know nothing about the sides as to whether they are congruent. So yes, this one, we could say that they were congruent. We cannot say that those are congruent because we don't know anything about the sides. No info about sides. So we cannot say that they are congruent. Okay. All right, let's look at these guys. Angle, side, angle. Now it looks like in both of these triangles, I only have three measurements. So let's go ahead and find those third measurements really quick. How do I do that again? All I do is take 180, subtract 45, subtract 61. I get 74 right there. So that's 74 degrees. And look, I do have a congruent angle there and there. I have a congruent angle here, and I have a congruent angle here. And let's see, 180 minus 74 minus 61. I have a feeling that's 45, and yes it is. So this is 45 degrees. So I have yet a third congruent angle there. Now my question is, do I have angle side angle? And what I see is let me use a different color, see if I can make it stand out anymore. I have an angle, and the side between, an angle, and an angle, and those are the same angles, 45, 45, 61, 61, and the side between, yes, those are congruent. So yes, I do have angle side angle. So yes, these triangles are congruent. I'm going to list my angles, sides, and angles that are congruent. So I'm going to start off angle A is congruent to which angle over here? Angle D. As far as the side, I'm going to say AC is congruent to, and again, make sure you go in the same order. A was at the 45, so D has to go, or is with the 45, that has to go first here. And then the last angle, angle C, is congruent to angle F. So there's my angle side angle. Okay. All right. So next one, I see angle side angle right there. I just have to see, is that going to match up with angle side angle over here? And I see angle and I see side, and that is looking promising if this is 110 degrees. So what do I do to find out if that's 110 degrees? I go to my calculator and I do 180 minus 38 minus 31, and it's 111 degrees. What? Did I type that in right? Let me double check. 180 minus 38 minus 31, 111. So what is this one? 180 minus 110 minus 31. That one's 39 degrees. So because those do not match up, I have angle and I have side, but I do not have that other angle. So I can say, no, they are not congruent because I do not have ASA. 111 degrees is not equal to 110 degrees. So even though they look like they're going to make it, they don't in that case. Okay? All right, let's go on to the next page. How about this one? Angle. Okay. Side. Now you notice they share a side. Well, this side in this triangle, isn't that going to be the same length as that side in this triangle? Because it's the same length, right? It's the same side. It's just being counted for two different angles, or two different triangles. So those are congruent, and those happen to be between my other set of congruent angles. So I do have angle side angle. They are congruent based on that. I'm going to go ahead and give these values A, B, C, and D so that I can list my angle side angle. So I'm going to start off with the one with the single little arc there. I'm going to call that angle ACB. Oops. ACB is congruent to what other angle? And I need to write it in order. A is the one that doesn't have anything, so that would be corresponding to D. D is going with B. That's got to be my single arc. So DBC is the way I would say this angle and this angle being congruent. The side. Okay, so I'm going to talk about the side with regards to triangle ABC first. I'm going to call that side BC, going from the 2 arc to the 1 arc. And then that would be congruent to over here. The 2 arc to the 1 arc is actually CB this time. So in the other triangle, it's angled, or it's ordered differently. Again, keep track of what order you're writing it. 2 arcs to 1 arc, and then it flips around for 2 arcs to 1 arc here. And then that third angle, or that second angle, sorry, is going to be the ones that have the double on it. So again, I'm going to start with triangle ABC up here, and I'm going to say angle ABC is congruent to what goes with A, D, and then C is the one that has the two arcs on it, and then B. So there's my angle side angle statement. Okay. All right, here we go now. We have angle, and we have a side. We have an angle, and we have a side, and we have another side. That's not, I don't have angle, side, angle. I have angle, side. Yeah, we're not going to go there. Okay, I can't do that one. So this one would be, no, we cannot use angle, side, angle to prove that they are congruent. Does that mean they're not congruent triangles? It doesn't mean that they're not congruent triangles. They may be congruent. We don't know. We just know that we can't use angle, side, angle as our justification for that. Okay? All right. So these last ones then, we need to determine, are they congruent? And we can use any one of these three things. We can use side, 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 and angle, side, angle. Now looking at number 7, I don't see any markings on any angles. So I'm not going to be looking for side, side, or angle, side, angle, unless I were to see maybe some vertical angles that I could say are congruent, which I don't here. So I'm going to be looking at side, side, side. So I have one set of sides marked congruent. Then I have 2 sets of sides congruent. And then this side right here, obviously, in this triangle and in that triangle, they're going to be the same length automatically because it's the same segment that's being used as a side in both this triangle and this triangle. So in this one, I do have side, side, side. Again, I'm going to put letters in here because the way I can prove that I have side, side, side is by listing my side, side, side congruent statements. So I'm going to start off with AC, because that's the one that has one little tick mark on it. That is congruent to, I'm starting with the letter that's on the 2 tick side of that, right, that connects to the 2 tick side. So here's my 1 tick. The 2 tick side would be D, and then C. That's the way I'm going to write those coordinated. Again, starting from the 1 tick side and going over. This one starting from the 1 tick side, I'm sorry, the 2 tick side and going over 2 tick side. The next side, let's do the one with 2 ticks. I'm going to do AB is congruent to, starting at the intersection of the 1 and 2. The intersection of the 1 and 2 is D. And then following the 2 tick side gets me to B. And then the last one would be BC. And let's see, is that congruent? Is it BC also? B being the intersection of the 2 and 3. It is BC here. So there's side 1, side 2, side 3, giving me side, side, side. Okay. Let's see. How about over here? I have an angle. Let's put letters in here. A, B, C, D, E. So I could say angle D is congruent to angle B, and that's an angle statement. I also have a side marked congruent. So I can say there's a side, and it looks like I can say DC is congruent to, starting at the one with the arc, that would be BC. And then do I have anything else that's congruent? Well, it doesn't look like anything else is marked congruent. However, there is this right angle right there. And even if that wasn't a right angle, what I do know is that this right here is going to be congruent to it because it's a vertical angle. So I'm going to say I have one other set of angles. And is it angle, side, angle? Is that side the included side of those 2 angles? Yes, it's the side that's connecting those 2 angles. It is the included side. So I'm going to say this angle, I'm going to call it DCE, is congruent to angle BCA. and that would be because of angle, side, angle, and you can see my statements right there showing that. Okay. All right, how about this one? A, B, C, D, E, F. Okay, so I see side, side, and the angle between those two sides. I see side, side, and the angle between those two sides, which makes me think we might be looking at side, angle, side. So let's see if we can do side, angle, side, if we can come up with those statements. Okay, so starting off, I'm going to do AC is congruent to, let's see, I went from the unmarked side of AC to the single arc following the double tick, so that would be FE. Okay, the angle between, that would be angle C, is congruent to angle E, and then the other side would be CB is congruent to, going from the, following the single tick mark, from the marked angle to the unmarked angle would be ED. I do have side, angle, side. Okay, now over here I have a pair of vertical angles that are not marked, and if I go ahead and mark those, I do have an angle that's congruent. I have two sides that are congruent. I have another two sides. We don't want to spell that one out. That's no good. I can't call it this. And there's just all sorts of issues. I would think this would be congruent to this side. I'm not thinking I can find anything. So we don't have anything that fits the SSS, SAS, or ASA. So we can just say not congruent. Okay. All right. Good luck with this one. Happy studying.